So I've got direct variation. I have joint. Oh, actually, I'm going to do inverse first. Variation. I've got joint, although your book calls this combined. Variation. I've never seen it really called combined. Usually most textbooks call it joint, and if you ever see it on the SAT, I imagine they'll call it joint. And in theory, they're word problems. You can make the word problems a little uglier, and we'll see it a little bit. But for the most part, this is, do you understand stuff? So let's make sure you understand what each of these mean. So when I say direct variation, and actually all of these things are to create an equation. And the way, if I create with x and y. So if I say y varies directly as x, right? So if I say y varies directly as x, they use other letters. In word problems, they may say, they'll actually put words in, like miles vary inversely as gas or something. I mean, they'll have, sometimes they use words, so you have to replace the words with letters. But right now, since we're introducing this whole thing, it's going to be y varies directly as x, and your job is to translate this. Actually, so here's how the problem. This is usually how, when it says y varies directly as x. So if you're not prone to take notes, you want to write this down. Right, y varies directly as x, and right below it, I want you to write y equals, as it says y varies. Think of varies as a fancy equal sign, and if it says directly as x, that means x stays on the same line. Now, the difference is, instead of just this being an equal sign, because it's variation, there is some magic, there's some number we have to find out. And that's typically called a k, and this is called the constant of variation. Apparently they have trouble spelling constant. I guess, yeah, C was taken, so I mean, the next K sound was the K, so that's where you get your constant of variation. So I get, if I give you the equation, it says y varies directly as x, then you instantly write down y equals x, and then your constant of variation, so it's y equals kx. The other one, other phrases are, I could say y varies inversely as x. And if you're doing y varies inversely, well, varies is still a fancy equal sign, so we write down y equals, but if it says inversely, that means that's going to create a fraction, and so I want you to put the x on the bottom. Technically, it's, inversely puts it's 1 over x, and you have your constant of variation. In practice, you usually write this as k over x. So if you see y varies inversely as x, you end up writing y is equal to k over x. And so you get this equation. And then last, I'm going to write down y varies jointly as x and z. And then when I say the word jointly, then that means I say y is equal to, go ahead and put my k, and jointly that just means I get two things. And so I get my two things, x and z, and I get my equation. So, I have to summarize today's lesson in, I don't know, maybe 5 minutes. You have to know what, when I say varies directly, varies inversely, and varies in jointly mean. And anytime you see this, that means you get you write down this equation. If I say y varies inversely, it's y equals k over x. If I say y varies jointly, basically whatever's here, those get multiplied. But all of these have your constant of variation. Right. So that's the main idea of the lesson. Right? We've got to make sure you know what these words mean. You need to know what, and I mean the official titles are direct, inverse, and joint variation. Again, your book uses combined. And now, if you see why it's called combined, it's like they're combining these two things. So, you get jointly or combined. I'll just go ahead and warn you. Most places use jointly. Very few books use combined. So, what does a problem look like? Well, here's what a problem looks like. First, you basically have three sentences. Right? So everybody write, this is our first example. So example 1 is, I'm going to start off with y varies directly as x. Then I'm going to say y equals 7 when x is equal to 3. And then I'll say find y when x is equal to 5. So this is the typical question. Right? They give you three pieces of information. Right? They say y varies directly as x. Then they give, and so each sentence basically tells you what to do. For this particular one, if I say y varies directly as x, that's telling you what equation you're going to use. So, what equation I'm going to use is the directly variation one, so that's going to be y is equal to kx. So this part gives me this. Next, the next thing we have to do is figure out what our constant of variation is. We've got to figure out what k is, and this next sentence gives us the information so that we can figure out what k is. It says when y equals 7, x equals 3. So basically it's telling you plug this stuff in. So when you plug this stuff in, it says, all right, so I get 7 is equal to k times 3. And now we have an equation we can solve. And when I solve this, it's pretty easy to solve at this point. End up with k is equal to 7 over 3. So sometimes you're going to have questions where they'll say, find the constant of variation, and your constant of variation is just k. We found k. And so now that we found k, now I can write my equation. So when I plug it back in, that's going to give me y is equal to 7 over 3x, and here is my equation. All right? So this is for sentence 1. These two things are for sentence 2. Sometimes they ask for the constant, meaning you just have to give the number. Sometimes you're asked for, what's the relationship between x and y, and so you have to do this. But these two are two of the sort of the answers to sentence 2. Then sentence 3, I'll call this 2a, and I'll call this 2b. And then to answer question 3, it says find y when x is equal to 5. Well, that simply says, all right, if this is your equation, what happens when x is equal to 5? And so what happens when x equals 5? We end up with y is equal to 7 over 3 times 5. And so we end up with 35 over 3. So the boring, I honestly, this is the reason why it was taught in algebra. It's typically taught in algebra 1. There's nothing super tricky going on in it. You have to know, you have to know what the, computer's very slow. You have to know what these words mean so you get this equation. They give you a couple of numbers to plug in, so you plug them in. After you plug them in, then it's pretty easy to figure out what your constant of variation is. write your equation. Once you get your equation, then you get your number. That's how it works. So, your turn. So if I tell you y varies directly as x, okay, and then I'll say y is equal to 6 when x is equal to 7. And I'll switch it up a little bit. Find x when y is equal to 11. So, solve that problem, and when you finish, do the electronic raise your hand. All right. So again, there's not much going on here. I mean, the first thing is it says y varies directly as x, so that's going to be y equals some number times x. We got to figure out what the number is. How do you do it? Well, I give you these things. I'll tell you y equals 6 when x equals 7. So let's see, there's a 6 equals k times 7. So I just found out k is equal to 6 over 7. So now I get my equation, y is equal to 6 over 7x. And a little sneaky, I ask, find x when y is equal to 11. So I plug the y equals 11. I get 11 is equal to 6 over 7x. And you got to do a little work. So we're going to multiply times 7 over 6 times 7 over 6. X is equal to 77 over 6. And there's your answer. And for the most part, that's how every single one of these problems works. Right? We're going to go through a couple more examples, and then I'm going to get to the tricky stuff. But the main thing is I've got to make sure you understand. If I says when you see y varies directly, how do you interpret that? Right? Well, I got two others. So how do I interpret if I talk about where y varies inversely as x, right? Move that down. Let's see. Here, we'll change the wording. When x is equal to 3, y equals 2. Find y when x is equal to 5. Right? So same wording, everything. It's all this. They pretty much there's not a lot of, pardon the pun, variation in the way they ask the question. So you look at it and like the first sentence, that's an A, right? It says y varies inversely as x. Well, if y varies inversely as x, then that means we're going to get y equals, in this case, I'm going to have k over x. The inversely means the x goes on the bottom. So I get my equation. Now my job is I got to figure out what k is. So to figure out what k is, they tell me x is 3 and y is 2. So let's see, that's 2 is equal to k over 3. And end up with k is equal to 6. Now that I know k equals 6, I can write my equation as y is equal to 6 over x. And next it says find y when x equals 5. So y equals 6 over 5, and we found our answer. Again, there's not much to these, right? The biggest thing is, can you translate this? And actually, I want to talk about the interesting problem. So we're this next problem I want you to do on your own, and do the electronic raise your hand when you've got it. So if I tell you y varies jointly as x and z, I'll say when x is equal to 3 and z equals 1/2, y equals 7. Find y when x is equal to 2 and z is equal to -3. Okay, 30 more seconds. All right, so let's look at this. Step 1, it says y varies jointly as x and z, so that's, I get my fancy equals, varies, it's going to be y equals k. It says jointly as x and z, so I get an x and a z. That's, first priority, write down your equation. Second, you got to figure out what your constant is, and I give you stuff. I'll tell you x is 3. Basically, plug in all the values in the next line. So I get a 7 is equal to k, x is 3, z is 1/2, which is the same thing as 7 is equal to k times 3 over 2. So to solve for k, and multiply by 2 over 3, so I end up with k is equal to 14 over 3. And so now I end up with y is equal to 14 over 3, and I have an x and a z, and I get my equation. Now it says, what's y? Usually I don't say find y. The reason you will never see the word find y on the SAT is like you can literally say, oh, look, found it. It's right here. Usually they say, what is the value of y? But this is a lot shorter to write, which is why I do it. And so y is equal to 14 over 3. Let's see, x is 2. And then z is negative 3. Well, when I look at this, 3's cancel and end up with y is equal to negative 28. So everybody unraise your hand just for a second. All right. Everybody unclick. All right. All right, close enough. All right. Do the electronic hand raise if this makes sense. Okay. Perfect. To me, this is really an Algebra 1 topic. I don't know why it's in Algebra 2, but, you know, it can't get that hard. The only way that it gets harder is instead of saying y varies jointly as x and z, they'll give you words. Actually, what they could say is, you know, they could say distance varies directly as time. You know, that, and it's, like if I actually said the word, you know, if I actually say, you know, if I say distance varies directly as time, how I translate that is d is equal to some number times t, right? So, I mean, that's, and then they'll even tell you, okay, you know, the distance in this, they'll give you the distance, they'll give you the time, you figure out what k is, and you go through the problem. So that's really, as far as this variation stuff goes, that's as tricky as it gets. Until I tweak it a bit. Just to kind of prepare you, your homework, it's a worksheet I sent out. I thought about assigning the problems out of the book, but I didn't like it. So the first part of it is identify what kind of variation it is. So, you know, let's say I give you y is equal, let's say I tell you a is equal to k over b, right? So if you see some sort of fraction, a equal to k over b, and I said, what kind of variation this is? Well, if you're dividing, this is inverse. Right? If you, and they play around with the letters. I could say I could say j is equal to k times ab. Well, if you look at this, you think, oh, well, this is going to be joint variation or combined, because this is from our textbook, and I don't know why they use combined, but they do. So if you look at your homework, you'll say, all right, you've got this massive bunch of problems. You don't have to do any work for most of them. You're just literally, okay, is it inverse, is it joint, is it direct? All right, but here are the interesting problems. And you want to write these down, because Alex actually has some of these, so you could expect to see some of these on your test. I'm going to give you a chart. I want everybody to write this chart down. We got 1, 2, 3, 2, 4, and 6. Right? And I want to know what kind of variation, right? So I want you to write, given a chart, I want to find out a variation equation. Right. How do you find a variation equation if I just give you a list of numbers? If I give you a chart, I give you x and y values. I want a variation equation. All right? And when I give you these, the one thing you want to make sure you look for, because sometimes it's tricky, you want to make sure that the x's are going in, they don't have to be equally spaced. Because if I look at this, you know, they're not necessarily equally, I mean, this is equally spaced because it's the first example. It goes 1, 2, 3. They don't have to be equally spaced, but they do, you need to make sure that x is increasing. So if x is, and if it's not, I mean, think of each of these as coordinates, so you need to adjust, like move the coordinate around if you need to. But, so you have to make sure that x is increasing, and given, and then you look at the y values. Now, you're going to have two choices here. You're either going to pick direct, or you're going to pick inverse. And how do you know if it's direct or inverse? Here's how you know. Make sure the x's are increasing. If the y is also increasing, then that means it's direct. If the x is increasing and the y is decreasing, that's inverse. And now you kind of get the idea where they come up with the name direct and inverse. Direct is, as x increases, y increases. They're doing the same thing. They're either both increasing or both decreasing, depending on how the chart works. It's inverse if they're going in two different directions, where x is getting bigger and y is getting smaller. That's an inverse. Right? So, given this chart, so there's two things we have to do. If I give you a chart, the first thing you have to do is figure out, is it direct or inverse? Right? And then after you determine that it's direct or inverse, then I want the equation. Right? And so here's how that works. First, if you notice, well, this is increasing and this is increasing, right? And since these are both, x and y are both increasing, I know this is going to be direct. And if it's direct, I know it's going to be y is equal to k times x. And now my job is, I've got to figure out what k is. So to figure out what k is, I need to pick a value. Right? And so if I pick a value, well, I'll pick this one. X is 1, y is 2, and x is 1. So if y is 2, when x is 1, well, I just figured out that k is equal to 2. So if I know that k is equal to 2, then I know I end up y is equal to 2 times x. And so I found out my equation. Let's say you didn't pick that. Let's say you pick this point. Well, if I pick 4 is equal to k times 2, well, I just found out that k is still equal to 2. Or if I pick this one. Okay? So, it doesn't matter which point you pick. I always pick the smaller numbers. We still end up with our constant of variation. All right? Your turn. So here's your chart. So I'm going to give you the x and y chart. And this is 5, 10, 15, 2, 4, and 6. And I want you to write the variation equation. And do the electronic hand raise once you've got it. Thirty more seconds. Okay. All right. Well, in this case, they're both increasing. Notice x's are increasing, y's are increasing. Anytime they're both increasing, then I know it's going to be direct variation, so it's going to end up being y is equal to k times x. Got to figure out what k is. So let's see, there's a 2 is equal to k times 5, so k is equal to 2 over 5. And that's y is equal to 2 over 5x. So there's our equation. Hopefully that's not too bad. Here's an application. I want everyone to write this chart. And your job, after you've got that chart, oh, guess I could call this X and call this Y, or call that Y, call it X. It doesn't really matter. Your job is to figure out what goes in this box and what goes into this box. And so how do you do that? Well, the first thing you have to do is identify that this actually is direct variation. Because if you look, okay, these are increasing, these are increasing. Since everything's increasing, this is direct variation. And if it's direct variation, you can go through and figure out each part. So, if it's direct variation, I know that I've got y is equal to some number times x. And so to figure out what, it says y is 1 when x is 3, so k is equal to 1/3. And that gives me y is equal to 1/3 x. And let's see, to figure this part out, let's see, if y is 5, so if I put a 5 here, I get 1/3 x, and so end up with x is equal to 15. So I know that's a 15. If x is a 27, I get y is equal to 1/3 times 27, and so I end up with a 9. All right, your turn. And I'll go ahead and tell you it's direct variation. So -8. That's a -8, -12. So I'm going to give you a couple of minutes to do this one. It's direct variation. And then I'm going to give you a shortcut. No. Guess I should make that an x or a y. It doesn't matter what you call x and y. It doesn't change how you do the problem. All right. So you could do this problem the exact same way as you did the other. But, you could make up the equation and plug in, and that's not really that bad. But I want to bring your attention back to this last chart. And I like patterns. And what I'd like you to notice about this pattern in this chart, the very last problem that we did, or you can look at one of the previous ones, actually even works for these up here. When I look at this, do you notice if I do 2 divided by 1, I get 2. If I do 4 divided by 2, I get 2. If I do 6 divided by 3, I get 2. So if I do this divided by this, I get the same number. Same thing happens over here. If I do 2 over 5, well, that gives me 2/5. If I do 4 over 10, I get 2/5. If I do 6 over 15, that reduces to 2/5. So anytime there's a direct variation, what we know is, either this over this is constant or this over this is constant. Like if you look at this problem, 3 over 1 is 3, 12 over 4 is 3. What had to go here? Well, something over 5 is better be 3, and so that's why this has got to be 15. This over this has got to be 3. Oh, that's got to be a 9. So when I look at this, I see negative 8 over 2. Well, that's got to, my goal is to get negative 4. See, this over this gives me a negative 4. So this over this better be a negative 4, which forces that to be a negative 16. This over this better be a negative 4. That's going to give me a negative 5. So sometimes, with this chart, I didn't say find the equation. I said fill in the blanks. And if you just have to fill in the blanks, that's kind of a shortcut. I've only got a few minutes. I want to talk about the inverse one, and so that's actually going to be quite a bit quicker. So when I start, I get x over y, and I get 1, 2, and 4, and then I get 40, 20, and 10. And so our job is to figure out, I want to find the equation, but I also wanted to give you a chart of something that actually represents an inverse. Right. And in this case, notice how the x's are increasing. In this case, the y's are decreasing. They're going in different directions. Anytime they're going in different directions, that's going to represent an inverse. So how do we create it? Well, if it's an inverse, that's going to give me y is equal to k over x. And I've got to figure out what k is. So that's 40 is equal to k over 1. Oh, look, k is equal to, I end up with k is equal to 40. So I end up with my equation, y equals 40 over x. Now that's one part of the story. That gives us our equation. Here's the interesting part with inverse. Just like with direct variation, there's some sort of pattern between the numbers, between x and y. Like in this case, if you do this divided by this, this divided by this, this divided by this, you get the same number. The same thing happens with inverses, except you multiply. Notice that 1 times 40 is 40, 2 times 20 is 40, 4 times 10 is 40, which is why I picked those numbers. So when you have a chart, those get multiplied. So using that, here's your chart. This will be our last problem, and I know the bell's about to ring, so I'll have to end here. But if this is your chart, notice how this is decreasing, this is increasing, therefore it's inverse. And if it's inverse, that means when you multiply the two things together, you better get the same number. Like this times this is 72. This times this is 72. So this times this better be 72. Well, the only way that's going to work is if that's a 9. And this times this better be 72. And the only way that's going to work is if that's an 8. So those are interesting values. All right. Oh, whoops. Someone asked a question. I'm sorry, I had a different screen. Oh, or you already put the answer up from before. All right. So it is now 9:05. Have a nice day. Tonight's homework isn't too bad.